So we're looking at surds. Surds are square root numbers that do not give whole numbers. So a typical example of surds is root 3. Another example would be root 7. These square root numbers do not produce whole numbers. So there are a few aspects of surds that we're going to look at. We're going to explore some of these, and the first one we're looking at is multiplying surds. So there are some basic rules that would be useful while solving problems involving multiplication. The first one here is root A times root B will give you root A times root B. So an example of this would be example 1. We have root 11 times root 2. That would give us, following this approach here, that would give us root 11 times 2. And here we have root 22. I'll just move this up. Don't forget, if you have any question, don't hesitate to ask in the comment section below. So another approach we can use in solving multiplication problem using surd is what I call m root a times n root b. That gives us m times n root a times b. So let's take example 2. Here, a typical example would be 2 root 2 times 3 root 5. Following this same principle, we're going to call this 2 times 3. We multiply the integers and multiply the square root numbers. So we have 2 times 3, and we have the root 2 times 5. In this case, we're going to have 2 times 3 gives us 6, and 2 times 5 gives us 10. So here we have 6 root 10. That's quite interesting. Another aspect is root a squared. When you have a squared number within a square root, this is what we do. We can break it down first and say a times a, and we can further break it down as a root a times root a, and when root a multiplies root a, it gives us a. Therefore, root squared a, or root a squared, is the same as a. I'm going to give an example using this approach. An example would be example 3. root 6 to the power 2. So what we do here is we already know that a number that is a squared number within a square root is the number itself. So here we're going to have 6 as our answer. So in most cases, it's not as easy as it looks here, because they usually combine different rules in one question. So I'm going to give a good example where we can apply these rules and approaches that I've mentioned earlier on. Root A times B, it equals root A times B. And the second one, M root A times N root B, gives us M times N root A times B. And a squared number within a square root is the number itself. So here we have example 4. I'm going to give an example that would include all the 3 approaches or rules that I've mentioned earlier on. So here we have root 4 squared times 3 root 2 times 5 root 3. So what we do here is, that would be 1. The coefficient of this root 4 squared will be 1. So here we go. We're going to have 1 times the coefficient of root 2, that's 3, times 5. And we have the root here, 4 squared, times 2, times 3. So here we have 1 times 3 times 5 gives us 15. And here we have 4 squared. 4 squared within a square root gives us 4. So we take it out. And here we have 2 times 3 gives us 6. So we're going to carry on. 4 times 15 would be 60. And here we have root 6. So our answer here is 60 root 6.